Okay, folks, once again, have any volume to this thing? And so this is going to be our last, I think, day of actual proper class where we're learning something new. On Wednesday, we're going to do a review session, which means on Wednesday you should bring loads of questions, because the more questions you have, the more I can talk, right? So you know, anything and everything, please bring it on Wednesday, and yeah, that's the plan. Okay, so we're finishing up the Levitt paper today, which means we're getting to what he actually did, right? We talked about how he went about doing it. He has this problem where we have candidate quality is likely to affect spending, and it's also likely to affect vote shares, naturally. And so if we leave candidate quality out, which we have to, it's going to look, even if spending didn't matter, it would look like spending mattered, because quality affected spending, and that effect, and even if that doesn't do anything, it ends up being a proxy for spending. Slow down. It ends up being a proxy for candidate quality anyway, right? And so his solution to this is to look at a subset, a very, 10% of the races where quality is likely not to be changing over time, right? So this is the repeat challengers, where the same two people go up against each other several times. And then, okay, they have certain candidate qualities, but in those 2 or 3 races, the candidate quality presumably isn't changing very much. And his conceit is that it's not changing at all. In which case, the only difference there is the spending and the other characteristics, because the quality is staying the same. And so he can adjust he can look at the spending, and the spending being different is the only thing that's likely to affect the change in vote shares in that story. Okay, so that's his little preamble, which you should read. And then after the introduction, you should start skimming. And the purpose of the skimming is to get a feeling what an empirical paper looks like. Okay, and then we get to table 1. And I'm going to talk about each of the tables, because partly we want to see what he gets. But in the sort of the bigger picture, I've already told you everything I want you to come away from this paper. That is, what the basic problem is, that there's this problem of omitted variables, and it's likely to be particularly strong in this case, and it's likely to bias our results upward, and his clever way of dealing with it. Okay, that's what I mostly want you to come away with. But now we're going to talk about his results. And what I want you to come away with from this is an idea of what an empirical paper looks like and how you should go about reading a paper, any paper, or indeed anything in life, but in particular an economics paper, an academic paper, how you should go about reading it and the attitude you should have towards it. And this is, of course, opinion, but of course it's my opinion, and therefore it is right. This is known fact. But you should treat it kind of like advertising. Right? If a firm advertises to you, you know they have a point of view. Right? Just because they're advertising doesn't mean it's a bad product, but they are trying to sell you a product. Right? And when you look at advertising, you say to yourself, okay, they're probably not lying, but they're only going to show the good sides, right? They're going to try to convince me that this is a good product, and you take that into account when you look at the advertising, right? Which is, of course, why they like to use YouTube personalities, because then they can pretend, oh, no, that's just a review. But it's still advertising, and we know this, right? Right. So you should think about the same thing. Each thing that's going into this paper, each thing that he's showing us, is him trying to convince us of something. And you should be aware that he's trying to convince you of something. Now, just because he's trying to convince you of something doesn't mean that it's not true. It may well be true. If he's a good scientist, it'll be a true thing that he's trying to convince you of. Because what happened is he spent 1,000 hours looking at this data all sorts of different ways and working with it. He knows far, far more about this data than he can ever present here. So he has to, even in the best case, he has to convince you of the things that he's learned in a small amount of space. So even if you totally trust the guy, I have no reason not to trust the guy, right? Even if we totally trust the guy, still he's condensing his knowledge down to something small to try to convince us of that, right? And it is also possible that even if we totally trust him, that he didn't think to look at certain things that really he should have thought to look at. So when we're looking at this, we should say, what is he trying to convince us of in each of these tables? So here, what is he trying to convince us of? Well, what does he give us? He gets all the contested elections, the first meetings, and the later meetings. Okay? So what he's trying to convince us of here is that this is kind of normal data. That is, it's not, it just give us a feeling so we don't feel like the data is some mystery to us, trying to give us some information about it. And he's trying to show that, look, these first meetings and these second meetings are kind of broadly similar. Okay? Now, they're not exactly the same. You can see that the success rate for incumbents seeking re-election is 94% and only 90% in later meetings. And so on. But he's basically just trying to give us a feeling for the data so that we don't feel like it's a mystery to us. Now, these are obviously summary statistics. And so you could have gone in, like if you're just sort of reading like blindly, you say, okay, what's it going to tell me about the data? But you should really go in saying, well, what do I want to know about the data? Right? You should think for yourself first, like what would I like to know about it? And the stuff that he's presenting may or may not be that sort of stuff. Right. So this is sort of a typical first table in an empirical paper, just sort of giving you an overview of the data. And typically, there's not a lot of skeletons hidden in this one, but sometimes there can be. But what he really wants us to do is to compare this with this, right? Here, this is all the contested election, all 2,700, and these are his subset of the data, right? So he's hoping that we'll come away with this, with the impression that, okay, he's throwing out all the guys that didn't have repeat challengers, but he's hoping we come away with the impression like, those are more or less like all the elections, right? Here he's got all the elections, and here he's just got the subset of the ones where we have repeat challengers. And he wants us to feel that these are kind of the same, right? Now, he doesn't need this, right? It would be perfectly reasonable and perfectly good contribution for him to say, we're looking at only these repeat challengers. We know that that's not everything. It's only like 10% of the elections. But at least we'll know something about these 10% of the elections that we didn't know before. Okay? But he wants more. He wants us to think that this is true of all elections. Whatever we learn with this 10% is going to be true about all the elections that are out there. And that may or may not be true. And so he's presented us with descriptive statistics that make it feel that way. The percentage of the vote for Democrats, 54% in the total sample in all the elections, whereas 55% in these repeat challengers. That seems kind of similar, right? It feels like it's the same, that this subsample is reasonably representative of the whole sample. Number of incumbents, the success rate seems the same at the first meeting, maybe not at the later meetings. All these things seem broadly similar. Obviously, the amount spent, right, for incumbents is roughly, vaguely the same on the first meeting, but then higher on the second meeting. So it does seem like incumbents spend less at the first meeting and then more at the later meeting. So there's something different going on there, but it doesn't seem like totally out of whack. Challengers spend about the same at the first meeting and then more at the second meeting. And for open seats, this is the first meeting ones is way less than the open seats that aren't repeated, which is an interesting thing. Okay? So this is the only one that stands out to me as being like way different than the full sample. But of course, this is an advertisement, right? This is an advertisement saying these groups are the same. The subsample is the same as the full thing, right? And so we can trust him that he's not lying about it. I'm nothing against Mr. Levitt, just in general. Scientists have been known to lie. But we will trust him that this is the facts, but is it what we wanted to know? Like if you set out and say, are these things the same? Aren't they the same? This repeat challenger stuff, is that the same as all the elections? Well, my personal opinion is that I wouldn't think that they would be, because there's a reason why the same guys went up several times, right? Like if I go up against, I can think of two reasons why a challenger might go up against the same guy twice, right? One reason would be, it's some district, let's say it's a completely Republican district, like it's always going to be a Republican, always going to be a Republican, always going to be a Republican. But the Democrats want someone to run. And so they go to George and they say, George, it's a losing job, it's a sucker's game, but we want someone there just so that we're contesting the election, so we don't disappear from the face of the earth. So George, could you please do it? And George says, okay, I'll take one for the team. And maybe it'll help advertise my used car business, so that's good. And so George runs, used car business flourishes, it's lovely, but he loses badly. And then the next time they say, well, George, you did it last time, could you continue doing it? Okay? And this is a situation where they're sending up a guy to lose, and they're sending the same guy up over and over again. Okay? Another situation that could happen is that it's a Republican district, and some sucker runs, but he does remarkably well. My God, he did well. Let's send that boy up again. Now let's give him some money, right? And so both of these are special situations, right? Now we don't know in general what the case is, and I guess the thing we're supposed to come away with this is a feeling like, yeah, it's not like it's random, this who runs the second time and who doesn't, but it's not so far off of what you would expect, right? This is the amount spent. This, let's see, what do we have here? Campaign spending. Yeah. So the challengers spend about the same as on average, but the second time they come up, they spend way more. So this suggests the second story, right? This suggests a story where people were surprised how well they did the second time, and then they were willing to fund them the second time. You were surprised the first time and willing to fund them the second time. Okay? Now, it is totally up to you how representative you think these things are, but you should be thinking, we're going to be learning something from the fact that, from these repeat challengers, this subset, this 10% of the data, and you should be wondering how much we could generalize that to the whole thing, to just elections in general. Okay. Enough on this. Table 2. Okay, let's see table 3. Okay, here's table 3. I'm going to start with table 3. He talks a little bit about it first, so we'll go. This is, so with table 2 and table 3, what he's trying to show is that, okay, maybe you don't buy that these are exactly the same information in the subsample versus the whole thing. But he wants to convince you that if you just look at this subsample, you are going to get kind of the same results that you would get in a regular regression. So what he's going to do is he's going to use just this subsample, just these repeat challengers, and he's going to look at it the way the existing literature did. Okay, so he's not going to do his pair thing. He's not going to do his difference trick. He's just going to run the same regressions that all the other guys had run, more or less, right? They all did a different thing, but the same sort of regressions that those guys did. And what he's hoping we'll come away with is, look, if you do the same things the other guys did, you get the same results with this subsample as you do with the whole thing. And so maybe this subsample isn't so special. Okay, this is what we're supposed to come away with. So he gives us the results for some famous papers in the literature, and there's hundreds of papers in the literature, but But these are sort of typical. And we get, let's see, 100,000 increase in $1990 gives you somewhere, if you're a challenger, gives you 4.2% extra votes, or depending on how you do it, 2.7% extra votes. And if these guys, somewhere 1.6 to 2.4. So that's how many extra votes you get if you're a challenger if you spend 100,000, okay, in percentage. Okay. And if you're an incumbent, the numbers are a bit less. And the reason this has been, the rationale that we've sort of given for this, although the numbers are just the numbers, is that challengers are introducing themselves, so there's an extra benefit for spending money. Okay? You just know my name now. Right. So that's the sort of standard thing you get in the literature. So if you go back and he does exactly, more or less, the same things that they do. So no new trickery here. He's just doing what they do. And you can see when he looks at the first meeting, challenger spending gives you 2.7%. 100,000 euros gives you 2.7% increase in vote share. The minus is just because of the way he set up his regression, but it's 2.7% increase in vote share. And in later meetings, about the same. And 3, I can't remember what table 3 is. We have to read. Okay. Incumbent spending gives a bit less, just as in the other regressions. And putting in the last election and playing around with it a bit. But it gives very much the same results that you would if you used the whole sample, right? And so this is, again, part of the argument that he's trying to convince us that this subsample is very similar in important ways to the whole sample. And so maybe what we learn with the subsample is actually something that's true of the whole sample as well. Okay. Now, of course, you can be convinced or not. Right? He's trying to convince us of something. And so when you're reading a paper, you should be aware that he's trying to convince you of something. So you should be arguing with him. Okay? Now, you may or may not find it convincing in the end, but just like an advertisement, you should be thinking, they're trying to convince me to buy the product. Let me also think about reasons not to buy the product, because they're not going to tell me. Right? Same thing here. It doesn't mean that it's not a good product. Right? Okay. Okay, and now we get his regression. So this is his main table, and his main column is this one. So let's talk about this column here, right? And this is the same thing. These numbers are exactly comparable to the other numbers. And so he has a challenger spending gives 0.3%. 100,000 euros of challenger spending increases the challenger's vote share by 0.3%. Remember, in the regular regression, it was 2.7, more or less. Right? So now it's 1/10 of the size of the other one. And incumbent spending before was 0.2, now it's 0.09, and it's not even statistically significant. Right? Now, not being statistically significant is not entirely damning because, of course, we have much less data. Right? Statistical significance is a measure of, do we have enough data to pick up the effect? Right? That's what it's about. And so if it's a big effect, even a little bit of data can pick it up. If it's not a big effect, you need a lot of data to pick it up. But the question statistical significance is asking is, do we have enough data to pick up the effect? And this is saying, for incumbent spending, we do not have enough data to identify the effect. So maybe the effect is too small, maybe our data is too small. But either way, we can't pick it up. Okay? So it could be 0, could be higher, but it's certainly not 0.2, right? It's well under 0.2 in the standard errors. Open seat spending is 0.17. An incumbent gets a 3.2% advantage. So if you're already holding the office, you're going to get 3.2% extra votes, which is lovely. If you have a scandal, that's not good, and various years, et cetera. Okay. Okay. So the important thing here is that both of these effects, both for the incumbent and for the challenger, are way, way, way smaller than they were in the general regression, right? And this is saying that, look, we had this bias. We had this upward bias because we weren't including candidate quality, right? We thought candidate quality is going to affect spending, and both spending and quality will affect votes. If we leave out candidate quality, it'll look like spending has a bigger effect on votes than it otherwise would, because we're leaving out the candidate quality. And this is saying, if we think, well, yeah, if we buy his conceit that the qualities stay the same across the two elections, this is saying that that bias was basically 90% of our effect, and only 10% of the effect was the actual spending, because we had 2.7 before, and it comes out to 0.3 now. So 10% of the effect is the spending, and the other was because of candidate quality that we were omitting. That was the bias. Okay. And so, yeah. Okay. Any questions about this? Okay. Now this is the main result, and yeah.
Did he address the fact that earlier you mentioned a lot of the benefit was because a challenger, they would get their name out there with funding. So if it was a re-challenge, would that benefit just be gone then? And is that something he couldn't do?
So the argument would be that that's why this number is still more than that number. But remember, that was a story that we made up, right? We made it up because the data keeps coming out that the challenger spending effect is bigger than the incumbent spending effect. And it's still doing that here, right? It's just they're very small. And so the argument would be that yeah, that's an effect. It's not huge here, but it's still an effect. But it's just a story we put on top. There's nothing, we haven't been able to test that, if you see what I mean. That's very plausible. So it could be that you're not picking it. See, that's a very, you should be arguing with these papers, right? And that's saying, yeah, okay, maybe we're missing an effect of spending because we're missing that initial get your name out. Now it's a known guy. That's a very good point. So maybe the actual effect is bigger. And that's saying that look, this subsample is not the same as our general sample in this way, right? Our subsample, because of the way we're differencing, we're not going to get that initial effect of just getting people to know who you are, right? And we're going to throw that out. He doesn't address that, but it is a reason to think that this number might be higher. Yeah. Okay. That's a very good point. I actually hadn't heard that one before, but it's true. I hadn't thought of it myself, but it's true. Okay. Okay, and then we have these other two columns. And these other two columns, I would guess that these are put in because a referee said, well, what about? And so he had to put them in. But I don't know. Maybe he had them in to begin with. But the idea here is that maybe the effect of spending isn't linear. Right? Maybe your initial spending gives you a lot of benefit, but then later spending gives you less benefit. And so these are various ways you could have. This is the benefit of spending is something times the square root of spending. And this is the benefit of spending is something times the natural log of spending. Okay, two different specifications that you could do to do that. And you get very similar results. The numbers are a bit different, but it's, again, very similar results, much less than the other one. I don't think there's anything else I want to say about the tables here. I think we're good. Yeah, we're good. Okay, so in this paper, he's very careful about how he says everything's fine. If you read his book, Freakonomics, which I don't recommend myself, but if you do, some people love it. But if you read the book Freakonomics, he has a section on this paper where he's much less scientific in tone. And there he suggests, look, the data is so clear, and yet politicians are spending money like there's no tomorrow. They're working really hard to raise money. They're a bunch of idiots. They don't even know their own profession. He doesn't quite say it that strongly, but that's the tone he gives. That, look, we've ran a regression. We found out that money doesn't matter very much for votes. So they're a bunch of idiots for putting in that effort. Okay. So I want to address that and also address those log regressions, just to. So let me put spending here. And put the marginal benefit and cost of spending here. Okay? Cost is a utility sort of thing. Benefit is a utility sort of thing. And so how much what's the cost of this spending? Okay, and so implicit in the linear regression, but more or less implicit, not necessarily implicit, but sort of the natural way you would think about this in the linear regression is that the benefit marginal benefit of spending in terms of votes is just constant. Right? That's kind of what they're thinking. It's a linear regression saying the benefit of this is constant, right? And then we say, an extra 100,000 gives you so much benefit in votes, right? And that translates into utility in some way. Okay? Now, that's fine, but if we look at the other ones, the other two columns, it's more like this. It's the benefit is either the natural log or the square root, and so the marginal benefit fit is something like that, a downward sloping thing, in both the log and the square root case. Right? That is, your initial spending gives you lots of benefit, and then the more you spend, the less the marginal benefit in terms of vote share. And that seems plausible, right? That, it falls in line with that getting to know you sort of thing, right? That your first spending, people find out who you are. Your next spending, they find out your positions on things. And by the time you're spending 100 million, they're sick of you, and they wish you would just go away. Right? This is how advertising works, no? So that seems plausible. And so it seems reasonable to do that. And so what it's saying, what the beta is saying is that that would be the point where you had your actual spending would give you the benefit you've got. And so there we're thinking it's really the marginal benefit, right? This is if you spent 100,000 more from where you are now, how many extra votes would you get? And that seems plausible. And before it was also the same thing. It was if you spent 100,000 more, how many votes you would get. But we kind of had in our mind that it was always the same, so it didn't really matter. It was 100,000 more or the first 100,000. But here, they're explicitly saying that it changes. Okay. Now, if we step back from this a little bit, though, and say, well, where did this actual spending come from? Well, it must have been, in some sense, endogenous, right? It must have come from somewhere. It's not just, spending is 3 million, and that's just, no, someone decided to make it 3 million, right? And so there must have been some, how much money should I raise versus how hard it is to raise that money versus the benefit of the thing. So if we were thinking about this as sort of an equilibrium thing, like both the incumbent and the challenger decide how much work to put into raising money. So we get marginal benefit, there must be some marginal cost as well, and that gives us the amount of spending. Right. And that seems reasonable. Like drawing it this way seems, I don't know, to me, like what seems reasonable, you decide for yourself what seems reasonable, obviously. But to me, that seems reasonable in the sense that when you're just starting out, maybe you haven't raised any money yet, you go to the people who love you, and some billionaire gives you a bunch of money because he loves you, and that's great. And the people who like you a lot are going to give you money pretty easily. The people who are trying to bribe you are going to give you money pretty easily. But then after a while, it gets harder and harder to raise money. Right? You can't just raise 100 trillion euros. That's going to be hard. But raising 50 euros is pretty easy. Right? And so it gets harder and harder and harder to raise the money. You have to make more and more phone calls to do it. You have to schmooze harder and harder. You have to suck up more and more and more. And it's just unpleasant. Right? And maybe it goes way up. Maybe you just can't raise more than a certain amount. Maybe there's just no donors out there. Right? So if we do that, that tells us the level of spending. And it also tells us the beta. Right, the 0.3 or whatever you get. This is the marginal benefit equals the marginal cost. What we capture in the regressions is how many votes you get if you increase your spending. And so it's telling us something about the marginal benefit of spending. Right? And it must be that this is where that's equal to the marginal cost of raising money. And this is true even in our linear case. If I go back to the linear case, if I can. In the linear case, we could have had a marginal cost like this. Right, so even if everything is linear, still, that's our marginal cost. Right? Okay, so if we go back to here. And so here we're in a situation which seems reasonable, that the benefit of spending goes down if you spend too much. If you spend 100 trillion euros on advertising, people are going to be so sick of you, they'll just, death threats and whatnot. Right? And so there's probably a decreasing marginal benefit, which he captures in those regressions. And there's probably an increasing marginal cost. Or it could be constant marginal cost. That would give you the same thing. And that would capture the marginal benefit of spending more. Okay? And so what the regression is telling us is that the marginal benefit of spending an extra 100,000 euros is 0.3% increase in your vote share. Okay? What it doesn't tell us, though, is this height. Right? Because all of our data are going to come from right around here. Right? Politicians are going to be going out there, and they're going to try to win elections, and so they're going to, raise money up till the marginal benefit is equal to the marginal cost. Now, sometimes they're going to be off. Like real life is messy, so they're not always going to be right at that point. They're going to be trying to guess the marginal benefit, and so we're going to get a lot of data points that are sort of right around this equilibrium. The politicians will be shooting for this equilibrium, but if we're sort of realistic, they're not always going to hit it every single time, but they're going to be in that neighborhood. What we won't have is any data from up here, right? Because people will be trying to do their best in the elections, right? Which means we know nothing about the shape of this thing. Right? We don't know how high it is here. We don't know how low it is here. We know nothing about that. And in fact, from the data, we cannot learn anything about that because all of our data is going to be right in this neighborhood. Right? So going from the marginal benefit of spending is 0.3 to politicians are fools for, and it is exaggerating what he said in his book, but politicians are fools for working so hard to get money is a big leap, because maybe that first 3 million gave them a huge benefit. But now they've spent enough, and the benefit now is quite small of one extra, because all we know is the equilibrium area. We don't know any of that. And we can't know any of that. Right? He made assumptions. He said, what if it's square root? What if it's natural log? But we have no reason to think that it's one or the other or any number of 100 million other sort of equations that we could put in there. We just don't know, and we can't know because that data just isn't there. Right? Because all the data is right around the equilibrium point. Okay. Questions about this? Because it's all coming from real elections. And in real elections, we're assuming those guys are raising the equilibrium amount of, right? So if we really wanted to set this up with an experiment, we would say, okay, let's send out this guy, Joe, and say, Joe, spend $100,000, and let's see what happens. And let's send out Carl, spend $200,000. And we'll spend out Susan, spend $300,000. Right, and they would say, look, the benefit of spending is so high. How come I can't spend more than 100,000? But we say, nope, it's an experiment. We're scientists here. You got to spend 100,000. But no real politician is going to do that. Right? If they see the benefit really high, they're going to keep spending. Right? They're going to keep raising money. So they're all going to be kind of in this neighborhood. Right? Now, the costs and benefits are going to be different for each guy, and so all the other bits in the regression are going to try to capture that. But in the end, we won't know anything from up here because no real politician will choose anything up there. Okay? Which just tells us, like what these regressions tell us, if we interpret it this way, is not that the benefit of spending is very small, but that the cost of raising money is really small. It's just not that hard to raise money, and therefore they raise a whole lot of it until the benefit gets low. Right? So even when you're raising this much, the cost is quite low, so that it was worth it for 0.3% of the votes. Okay? Now, maybe that 0.3% is crucial, and that's what gets you elected. So it's not like that 0.3% is trivial just because it's 0.3. It's whether you think it's going to get you elected or not. That's the key. Right? Yeah?
Is there examples in the data of like actuality candidates that go way past the equilibrium?
We couldn't know. Right? We couldn't know because we don't see the equilibrium, but we just see what they chose. Now, presumably, there's some candidates that just totally screw it up. Right? And there's some candidates that are billionaires. Right? And so for them, the marginal cost would be super low all the way out to, a couple $100 million. Right? It wouldn't, they wouldn't even notice the money. Right? And so, clearly in real life, people screw up. Right? And so there probably would be, but the trouble is we wouldn't know that they did. Right? We wouldn't know who that was that screwed up. And so we couldn't say, okay, we'll use these guys to look at the marginal effect, and we'll use these guys who screwed up and did way too low for the shape of the curve. We can't do that because we don't know who they are. Yeah. Which is a huge problem. Like we could probably get an idea of the shape of the curve around here if we were really careful, because people are going to be off a bit, right? But it seems unlikely that we're going to know much about the shape of the curve way down here at the low values, because how are you going to get that? Right? Now, you could maybe do that with countries like Canada, where they have caps on spending, limits on spending, but some people still go below. You could probably get some idea, because some people would be restricted kind of here. And so you get some information about kind of this area based on that if you worked really hard at it and you were clever. But way down here seems unlikely, because there are countries like Ireland where the limits are really strict, and so we probably are down here, but then everyone spends the full amount. And so you get no variation in spending to identify any of this stuff, right? So Ireland is probably in the area that's kind of up in here, but we don't really change our spending, so we can't really see that, right? Okay, that is the course. That's everything that's going to be on the exam. Next time I will talk about the exam. I'll just say a couple of things here. It is going to be an essay exam like before, like the last couple of years. It's going to be the same format. a few questions. I can't remember how many offhand. I'll give you an exact figure. I know people like that. You'll answer all the questions, and you'll know the points of the question. Allocate your time kind of proportionally to the points would be the appropriate thing to do. And we'll also have another one of the homeworks to give you a chance to help each other get better at writing these exam questions. But bring questions next time. Please bring questions next time, and I will answer them. Okay? And I'll talk in more detail about the exam.